Hello, my name is Robert Lwanga, and I'd like to present to you my PowerPoint, which is discovering new compounds for anti-cell proliferation activity. And my research mentor was Dr. Sadana. A little bit of background information is that a common treatment for cancer is the use of chemotherapy drugs, but this isn't the safest treatment since it carries risks to the user as it usually causes side effects. Most common side effects of chemotherapy drugs include nausea, vomiting, hair loss, and fatigue. Our objective for this, for our research, is to find new chemotherapy drugs that minimize the amount of side effects it gives a user. So for methods, I utilize two assays. The first assay was compound screening, in which we had compounds, 30 different synthetic compounds, and we tested them against cancer cells to see how well they can kill cancer cells. And for this one, for compound screening, the methods go, I did the optimal number of cells, which is 50,000 cells, into each well, to load it in their own wells. And then media was added so the final volume was 100 UL microliters. And for precision, I duplicated the wells of each well. And so then I added 10 microliters of compound into each well. And for my controls where PBS, doxorubicin were added into their own wells. And then afterwards, I did the MTT assay, in which I added 10 microliters of MTT were added and left to incubate for 3 hours. And then I add a detergent reagent and left that incubate for 2 hours and read the plate with a spectrophotometer. And the purpose of the MTT assay is basically to detect whether the cells are alive or not. If they're alive, then the well will turn purple, but if they're dead, the wells will stay yellow, since MTT is already yellow once you input it into the plate. And then once I found promising compounds, I then move over to the apoptosis necrosis assay, which is a assay used to detect whether cells died via apoptosis or necrosis. Apoptosis is a natural cell death, which is what we want to occur, while necrosis is a unnatural cell death, which we don't want to occur. And so once I gathered the promising compounds, I then plated 100,000 cancer cells and then treated them with the promising compounds, let them incubate for 2 days, and then added visual markers, and then visualize the results with the fluorescent microscope. Here are my results. On the left, you can see my results for MOLT4 cells, cancer cells, which are leukemia cancer cells, and on the right are my results for BXPC3, which are pancreatic cancer cells. And so these figures show the effect of the 30 compounds, which are titled the PM series, against the proliferation of the MOLT4 and BXPC3 series. PBS was used as a negative control, while doxorubicin was used as a positive control. Each compound was tested at a final concentration of 20 micromolar. And for my results for the apoptosis necrosis assay, so this figure shows the results of the promising compounds against MOLT4 cells, the leukemia cancer cells, via the fluorescent microscope. Blue dots represents alive cells, and green dots represent cells that have went through apoptosis. PBS was used as a negative control, and camptothecin was used as a positive control. And the compounds I used were the PM9, 10, and 11. And in conclusion, PM compounds 9, 10, 11, 12, 13, 14, and 27 are promising in inhibiting proliferation of MOLT4 and BXPC3 cells. This is mainly because they're able to get the average cell survival rate into 50% or less. In the future, I plan on testing these compounds on different cancer cell lines to see how well they compare. Thank you for watching.